we've talked about, hopefully it didn't make my mirror. We've talked about finding derivatives using that limit principles, like the definition of a limit. And we're going to go into finding derivatives other ways. But what I want to show you is, if I give you, we're going to go, I don't know, I'm saying mirror so many times. F of x equals x squared. Let's just do a basic one. Okay? And I want f prime of x. For right now, we're going to pretend that I didn't teach you anything about a power rule. We're just going to use the limit rule, limit formula, right? So we would do the limit as h approaches 0 of f of x plus h minus f of x all over h. Off to the side, I always find my f of x plus h. So I get x plus h squared, which gives me x squared plus 2xh plus h squared. Because the 2 on a binomial screams FOIL every single time you see it. I wish it did. I wish it popped up the page and was like, FOILing, distribute, skip 3 terms. You know? Wouldn't it be nice? So, we get the limit as h approaches 0 of x squared plus 2xh plus h squared. Then I have to minus all of f of x. It's only one term, but if it was a binomial, I'd have to remember to distribute it. And h. And then we discussed that anything without an h needs to cancel off, so I can take an h out so they can cancel. Correct? So the x squared and the negative x squared is canceled. And I'm left with the limit as h goes to 0. Take an h out. I'm left with 2x plus h divided by h. H is canceled. The moment they cancel, the problem is gone. And I can plug a 0 in. Now that is the first derivative. Cool. What the heck is the first derivative? Well, the first derivative is actually m tangent. M being slope. So it's actually the tangent slope. This is the general formula of the tangent slope for every single slope at any single point on the x squared graph. Okay? So what if I gave you the coordinate, what's the next word graph? I can pick anything. Let's go 2, 4. Now why can I pick 2, 4?
Because it's the point on the graph.
It's the point on the graph of x squared, which was the original, correct? So if I ever just give you an x on the original or a y on the original, can you get a point on the original? Yeah, you can plug it in for the x or the y in the original equation and get the other x or y, right? So I don't actually have to give you the total coordinate. I could just give you the x or give you the y, and you have to find them first before you can do any work. Okay? So, cool. There's my point. This is the tangent slope of, this is like the general tangent slope of every single point, and tangent slope's just touching one spot on a graph, correct? So what if I want the tangent slope at the point 2, 4? So if m tangent is 2x, m tangent at 2, 4 would be 2 times what? 2. So the slope of the tangent point at 2, 4 is 4, which is 4 over 1. So it rises up 4, right 1. Remember, you have to rise before you run, get out of bed. You have to rise before you run, or you're running in bed. If you're running before you're rising, you look foolish. So let's just sketch the graph, a real quick sketch. So I know I'm at 0, 0. I know I'm at 1, 1, negative 1, 1. I know I'm at 2, 4. And negative 2, 4. Pretend that's really drawn nicely. Okay. Now I'm saying that there is a tangent slope at 2, 4 of 4 over 1. And if I draw 4 over 1 from there, it will actually run tangent on it. So, I didn't make the graph very big. So if I go to 2, 4, which is this one, and I rise up 4, 1, 2, 3, 4, and I go over 1, it'll be like there, correct? Keeping in mind this is not graph paper, so not the most accurate. Then if I go from this point, and instead of going up 4, right 1, what could I do? Down 4, left 1. And if I connect to these, I get a tangent line. And you can do that for any point on the graph of x squared. So they might ask you for the tangent points. Every single time you've been doing the limit, and I told you, hey, you can check your derivative by plugging in a value, right? I've been saying that to you. And then you can plug the value into your actual derivative that you found, and it should match. Every time you're doing that, you're actually finding the tangent slope of that x value, whatever x value you're picking. That's what you're doing every single time, just seeing how you're doing it. So one thing they can ask you is for the tangent slope at that point, correct? So this is the tangent slope at 2, 4. Cool. The other thing they can ask us for is actually the equation of the tangent slope. So the actual equation of that line. Okay? Now, we can fill it into y equals mx plus b, but we have a point and we have slope, correct? We have slope. Our slope is 4. We have a point. It's 2, 4. We agree? There's something called point-slope form, which is a wonderful thing to use when you have a point and slope. Okay? Point-slope form is the slope formula rearranged. So I'm going to show it to you. So if we have m equals y2 minus y1 over x2 minus x1, what I can do is I can take this entire denominator and multiply it up, correct? So that's point-slope form. So point-slope form is y2 minus y1 equals m times x2 minus x1. It just doesn't really have the ones. And why doesn't it have the ones? Or it doesn't have the twos. Anyways, doesn't matter. We'll leave it like that for now. The reason why we don't have some of the things is because you have to keep an x and a y to make an equation, correct? We would substitute in x1 and x2 and y1 and y2 to get slope. Yes? We have to plug in 2 coordinates. Remember Mrs. Lepp was stupid in high school when she was Wagner? And she did x1, x2, y1, y2, labeled all of her points like that, and every single slope question was wrong, and I got a 0 on the test. In grade 10. It was the best of times. It was just actually the worst of times, is what it was. I labeled all my coordinates x1, x2, y1, y2. I tell you what. So, we don't want to get rid of the x and the y. We want to keep them, correct? So point-slope form is actually written like this. Y minus y1 equals m times x minus x1. And we fill our first point into there, right? We can keep the ones if you really want to. We only have 1 point, so we would fill it into there. But the y2 and the x2 don't get filled into because we don't have another coordinate, and we don't want to fill it in because we need x's and y's to make an equation. Okay? So, also, on your AP exam, sometimes it's just written in point-slope form like that. And then people do slope y-intercept form, and then they have to try and get it, they have to change their slope point form into y-intercept form, and it's a disaster. They put it like this on the non-calculator section, because then you don't really have to do anything. Once you have the point and you have the slope, you just plug it in and you're done. So we would have y minus, this is my x1 and my y1, which I learned is not x1, x2. At y minus 4 equals 4. X minus 2. Now this equation is helpful if it's in that form, because then you're done, right? You don't have to do any work. However, if I want to plug it into my calculator to see if it actually is a tangent, I'd have to get it into y equals form, right? So this is point-slope form. This is beautiful. They might make you do y slope y-intercept form. So I'd have to distribute my 4 through and then add the 4 over. So I'd get y equals 4x minus 8. Plus 4. So it's y equals 4x minus 4. Do you agree?
Yes.
Okay, cool. That shows it. So we know we're right. Okay? So that's if they ask me for the equation of a tangent, right? So both of these are equations of the tangent. The other equation they can ask you for is the equation of the normal. The normal is the one that's perpendicular at that point. What do we remember in grade 10 about slopes that are perpendicular? They're negative reciprocals. So if your slope of your tangent is 4 over 1, your slope of your normal is negative 1 over 4. So if your tangent slope is negative, your normal will be positive. If your tangent slope is positive, your normal will be negative, and it's just reciprocated, so it's flipped. So if they want the normal equation, don't know why I'm saying normal tangent. So if m tangent is 1 over 4, sorry, 4 over 1, then m normal will be what? It was positive, so it's now?
Negative.
It was 4 over 1, so now it's?
4. 1 over 4. 1 over 4.
Yeah, I heard you say 1, it was just really quiet before the 4. Yeah, totally. So now it doesn't change anything. We can still go y minus y1 equals m x minus x1. Our m is just different. So it's y minus 4 equals negative a quarter x minus 2. That's it. That's the only difference. That's all.
So what is the normal?
It's perpendicular. So if I solve through it, so this is my point slope form. If I go y equals, this being negative a quarter x, and then minus that times that is negative a half, positive a half, and then add 4. So I would get y equals negative a quarter x plus 9 over 2. Do we agree?
Yeah.
I need to remind me what that is, because it was negative a quarter.
X. 9 over 2. 9 over 2. Nathan nodded.
Plus, minus?
Plus.
Can't remember. I really need to make my window bigger. It's a trick. Come on. Oh, too far. Come on. Just perpendicular. So you could draw a 90-degree angle between those two lines. That's it. What is?
So couldn't it have any y value? Like it doesn't have to be plus 9 halves. It could just be anything, couldn't it?
No, it has to be plus 9 halves because that's what gets you the y-intercept. The plus 9 halves is the
Oh,
y-intercept.
intersect.
So your y-intercept and your slope have to.
Yeah.
That's it for today. You don't have to do anything on this. This is a glimpse. We start power rules tomorrow.